The AI SDK is one of the most popular AI libraries for developers right now. In this video, we're going to explore the benefits of using it and the changes implemented in V6. So without wasting any more time, let's dive into it. To start, let's build a chatbot using the OpenAI SDK. This will help us understand what Vercel's AI SDK solves. First, we import the SDK and create a client. Then we call the chat completion endpoint with our model and message. And here's what we get back. Take note of this response structure because it's about to change. Then Anthropic drops a new model which will operate better on your app, and you want to change that. So let's take a look at what we had to change. First of all was the import, then the client, then the method name, and then the way we access the response changed too. So there are 4 changes just to switch a provider. Not to mention a completely different output structure. We have the same data, totally different shape, and that's 2 providers with small differences. Now imagine 5 or 6 APIs, and every time you want to move to a new API, your team will have to relearn this and adjust the code as necessary. So here's the thing. The AI SDK solves real problems. You have one API to learn, you have consistent outputs, easy provider switching, and you have tools that make everything faster. So now that we know the benefits, let's write some code. First, let's install the AI SDK along with the provider packages we need. Then we'll create a new file called AI SDK basic.ts. And within that file, we'll import the generateText from AI and the provider separately. Now notice the separation here. This is a key design decision, and that's going to help us so much when we want to switch providers. Then we call generateText with the model and the prompt. And that's it. 2 properties and the SDK handles everything else. And to log the response, just a result.text will do. We don't have to dig through nested arrays. Now let's run this and notice we don't get the full response until the processing is done. This can cause some UX problems and can confuse some users. We'll address this once we talk about streaming. And just as a comparison, here's the result. Now what if we want to switch to Anthropic? All we have to do is change 2 lines, the import and the model. Now if we take a look at the response structure, it's the same. It's a different provider, same output shape, and there's no new learning curve or any code changes. Now if you want to add a system prompt, we can add the instructions, and it works the same across all the providers. And if you need more control, you can set the max output tokens and limit the response length and temperature to control the creativity. Both work consistently across all providers. Now let's move into streaming. When you are building a user-facing application, you don't want them to stare at the loading spinner for 10 seconds. You want to show them the response as it's being generated. So let's see how it works. We'll create a new file called stream-example.ts. Instead of generateText, we import streamText. Same pattern, different function. And this is one of my favorite things about the AI SDK. The API stays consistent across all operations. This time we will call on streamText with our GPT 5.2 model and a prompt. Now since the text arrives in chunks, we need to loop through the streams. A for or wait loop handled this nicely. Each iteration gives us the next piece of the text as it arrives. Now when we run it, you will see that instead of waiting for the whole text to finish, we are receiving it as it comes back. The stream is flowing in real time. The result gives us the text stream for real-time chunks plus promises for the full text and metadata once the stream is completed. Now by default, the stream comes in chunks as the model generates them, but we can control how we receive them. We can use the smooth stream, which is experimental, and set the chunking to line. It's that simple. Now when we run it, you'll see the output comes line by line instead of token by token. Each complete line shows up as a chunk. So when do you want to use each? Use streamText when you're building chatbots and assistant, writing long-form content, or when you want the interaction to feel quicker for the user. But if you want to summarize documents, translate text, or run a background task where a user doesn't mind waiting, use generateText. Always think about the user's experience when you're choosing. Okay, so we've seen how to generate and stream text on our backend, but honestly, no one wants to use a CLI tool to chat with an AI. So we need to build a frontend, and in this part, I'll show you how easy AI SDK makes it. Now, before we jump into the code, let's understand the problems we'd face building this from scratch. Step 1, we would have to convert the UI messages into model messages. So that means stripping out the IDs, timestamp, metadata, all the things that the model don't need. Step 2, we send to the model and handle the stream chunks coming back. And then step 3, convert those chunks back to the format we had initially so React can render it. Now that's a lot of plumbing. But luckily, AI SDK handles all of this for us. We're going to build this with Next.js because it's the easiest way to have both frontend and backend in one project. First, let's create the app directory structure. Within it, we'll create the API folder, and in Next.js, this is where all the backend API routes live. Inside the API folder, we'll create a chat folder. This groups all our chat-specific API endpoints together, keeping things organized. Now let's create the route.ts file. In Next.js, this is the handler file where we define what happens when requests come into the API/chat endpoint. We import 3 things from the AI SDK: streamText for streaming responses, convert to model messages to convert front-end messages to the format that a model understands, and the UI messages for TypeScript typing. Here's what we export to the post handler. As we discussed earlier, we use the convert to model messages to convert our UI messages to the model-specific format. It handles all the provided differences for us. Then we call the call streamText with the model and the converted messages. This starts the streaming process. Now we use the toUI messages stream response to convert the stream into a format React hook can understand. One method call and you have the properly formatted streaming response that the front end can work with. Now let's create the page.tsx. For the front end of our page.tsx, we will start by adding the useClient as a marker that this is a client component. Then we import the useChat hook, which will save us tons of lines of code if we were to implement this ourselves. We create a chat page component. First, we set up the state. Use state for managing the input field text, and use chat, which gives us the messages. Send messages to send new messages, and status to track if we are currently streaming. Next, we will define handle submit. This function prevents the default form behavior, checks if the input has text, sends the message using sendMessage, and clears the input field. Now for the UI, we create a flex container for the full viewport. Inside, we map through the messages array and display each one. Since the messages use the parts array since v5, we loop through these messages to extract the text content. And finally, we add the form at the bottom. The input field is bound to our state, and the button is disabled when we are actively streaming. We are also changing the button text while we are streaming to give feedback to the user. Now let's see what this looks like in action. Here's a chat interface we just built, a clean, functional chat UI where messages appear in real time as you type and send them. Next up is multimodality. We'll start sending images through the chat UI. First, we add useRef to our imports. We'll need to programmatically clear the file input after sending. Then, we add a state for storing selected files and ref to control the file input element. We add a hidden file input that accepts images. It's connected to our ref and updates states when files are selected. We add a style label that acts as the attachment button. Clicking it triggers the hidden file input. Now in v5 onwards, useChat no longer manages input. We use the useState instead. Let's also simplify the form with an inlines on submission. For now, just prevent default. We'll wire up the real logic next. And here's the magic. Just pass the text and files to send message, and the SDK handles the rest. Now after sending, we clear the text input, file state, and reset the file input element. Now let's update message rendering. First, we handle the text part as paragraphs. Next, we add image rendering. Check the part type and media type, and then render an image tag. And here's the best part. Our backend route doesn't need any changes. The AI SDK handles image files automatically. Now let's move on to structured outputs. Here's how structured data works in 4 steps. Step 1, you start with a raw input, a document, a prompt, whatever you need to extract the data from. Step 2, you define a XOT schema that describes the exact shape you want back. Step 3, the model processes your input and returns type JSON that match your schema. And step 4, your UI components consume that data with full type safety. No parsing, no guessing. Now, when would you want to use it? 1 is when you want to extract from entities and from documents. 2, when you want to classify or categorize content. And 3 is when you want to parse receipts, invoices, and forms that your application might consume in the future. Now, here's something important about the AI SDK in version 6. There are a few depreciations you should know about. First of all, the generate object has been depreciated. You now use generateText with output.object. Same for the stream object. It's now streamText with output.object. Now you may be asking why. Well, this unifies the API for text, object, and tools into one consistent pattern, which in my opinion makes it much cleaner to use. So let's start by writing some code and creating a structured output.ts file. Then let's install Zod, as we need that for defining our schemas. We import generateText and output from the AI SDK plus Zod for our schemas. The output helper tells generateText what structure we want back. Then we define our schemas. This basically tells the AI exactly what structure we expect back. Now we call generateText but pass output.object with our schemas. The output property is where the magic happens. It tells the SDK we want structured data back. Now again, if you look at step 15, notice how we wrap the Zod schema with our output.object. Again, this is a v6 pattern, which makes it that we have one unified API for all output types. And here's the typed object back from the model. Now, if we want an array, we can use the output array with an element schema. Each element in the array will match the schema we provide. Now, if we take a look at the output, it's an array with typed recipes. If you want to use structured outputs for classification, use output.choice with your options array. It's perfect for sentiment analysis, categorization, or any fixed choice output. The result is one value from the options array, which is fully type-safe. Again, for streaming the data, we can use the streamText with the same output helpers. Just swap generateText to streamText. And just like before, streamText returns immediately. No wait for the function itself, the stream carries updates as they are generated. Loop over the partial output stream to get the object as it builds. First, you might just get the name, then name plus ingredients, and so on. Perfect for that typing effect with structured data. Now, when you're generating arrays, use the element stream to get each complete item the moment it's done. First recipe arrives complete, then second, then third. This is perfect for rendering lists progressively. Now, let's introduce tools. Up until now, the AI could only respond with text, but with tools, the AI can actually take actions on your behalf. Read files, calls APIs, query databases. You define a capability and the model decides when to use it. Now, every tool has 3 parts. The description, which tells the model what the tool does. It uses this to decide when to call it. The input schema, which defines what parameters the tool accepts, and it's validated with Zod. And lastly, the execute, which is the actual code that runs when the model calls the tool. Let's jump into the code and create a lib folder, and within it, we'll create a tools.ts file. Now in this step, we're going to build a file manager tool, something that you'll probably use in production. We import 2 things, the tool helper from AI SDK, which wraps your function so the model can call it, and Zod for defining the input schema. Zod validates the model's parameters before the code runs, so you never get bad data. First, the description. This is critical. The model reads this to decide when to use this tool. If you write something vague like handles files, the model won't know when to call it. Be specific about what it does. Next, the input schema. This defines what parameters the model can pass to your tool. We use Zod here. The enum means that the model can only pick read, write, or delete. No hallucinated operation. Each field gets a describe, so the model understands what to pass. Finally, the execute function. This is the actual code that runs when the model calls the tool. It receives the validate input, already type safe thanks to Zod, and returns data back to the model. Whatever you return here, the model can use it in a response. We export tools as an object. This is what you'll pass the streamText later. Now here's the thing. We are letting AI delete files, and this is a little bit dangerous without some guardrails. So we can use something like needs approval, and that adds a human in the loop. The UI shows what the tool wants to do, and the user confirms. Then the execute runs. The problem is this blocks every single operation, even if it's just a harmless read operation. So what we can do is pass a function instead. Reads and writes run automatically, but deletes pause for confirmation. Now, since models are non-deterministic, they can be sloppy with schema. They might add extra fields or use the wrong types. To avoid that, we use strict and set it to true. This locks it down. The model can't deviate from your schema at all. No extra fields and no wrong types. Sometimes though, the model needs a little bit more guidance on how you actually want your tool to be called. We can use input examples, which is a few short prompts baked right in. The model sees these patterns and learns your conventions. That handles input. For outputs, we can also control what the model actually sees after the tool runs. ToModel output formats raw data into readable text for the model. This helps it write better responses. And now our tool is production ready. Now let's wire the tools into our API route. We import the tools object we just created, then pass it the streamText. The model now knows about our file manager tools and can decide when to use it. Now, one important safety measure: use stop when with step count is. This limits how many tool calls the model can chain together. Without this, the model can loop forever, calling tools, getting results, calling more tools. Here we are capping it at 5 steps. Now this is the output if the model decides to use your tool. You get tool calls with the tool name, a unique ID, and the argument it extracted from the conversation. After your function runs, the SDK sends the tool results back to the model. The model uses this data to formulate its response. That's why the ToModel output parameter matters. So here's how it all flows together. Step 1, messages. The user sends the messages to the application. Step 2 is where the model reads the messages and thinks about what it's going to do next and what tool to use. Step 3 is the execution. The SDK runs the execute function with the validated inputs. Step 4 is the result. The result comes back and gets passed to the model. And lastly, step 5, the response. The model either responds to the user or calls another tool if it needs more information. Now that's the agentic loop, and it keeps going until the model has everything it needs or hits a step limit. Now on the front end, we need to render these tool calls, but without proper types, you'd be guessing what properties exist. So let's fix that. We'll start by making a types.ts file. Now we'll import 2 things: UI message, which is the base message type, and infer UI tools, which extracts the types from your tools object. We also import our tool definition. Then the infer UI tools extracts the exact shape of inputs and outputs from our tools. Full autocomplete and no guessing. Now let's import that type into our page, and this connects our backend tool definitions to the front end, one source of truth. We pass my UI message as a generic to useChat. Now messages.parts is fully typed. TypeScript knows exactly what's in there. Check for the tool part type in messages.parts. Each tool gets its own type: tool files, tools weather, or whatever tools you've named. TypeScript narrows automatically. The trick is, tools have state machines. They are not just done or not done. When state input streaming or input is available, the tool is running. Show a loading indicator with the operation and a path so the user knows what's happening. If the tool call was a success, then the output available will be shown. That means that your execute function has completed and part.output contains the typed result. But of course, tools can fail, so we'll need to handle that too. If the tool fails and we get the output error, then we can use that error text to display to the user. And this is pretty much it. This is what you'll see in a real conversation. You'll see the responses, the failure, and the approval for user input. And that's it. That's the unified tool model in action. You get typed parts with state machines, no more guessing, just check the state and render accordingly. Now let's talk about tokens. If you've ever looked into your LLM provider bill and wondered where is that cost coming from, understanding tokens is essential. LLMs don't read text, they read tokens, roughly 3 to 4 characters each. Providers charge per token, so understanding usage means understanding cost. AI SDK tracks this automatically for us. Let's create token tracking.ts file. And we will start with our usual imports. There's nothing new here. And here we add the onFinish callback, which fires when the stream completes. It gives you the final token counts and why the model stopped. Did it finish naturally, hit a limit, or get interrupted? Perfect for logging costs and debugging. If you take a look, the usage includes input, output, total, plus optional cached and reasoning tokens. Next, let's talk about embeddings. Here's a high-level concept of how embeddings work. We start with text. We then convert that text into high-dimensional vectors. And then we take those vectors and plot it in semantic space where similar concepts are clustered together. Let's create the embedding.ts file and then import the embed functions from the AI SDK. Here we are specifying an embed model and the text we want to embed. And this is the result we get. Now, when you need to embed multiple texts, like indexing a document library, use embed many. It batches everything into a single API call, which is faster and more cost-effective than embedding one at a time. So you're probably wondering when to use embeddings. Use it for RAG when you want to retrieve relevant documents for an LLM context. Use it for semantic search, where you want to find things by meaning and not keywords. Clustering, which is auto-grouping similar content. Building recommendation system, which suggests item based on the vector similarity. Or deduplication, which detects near duplicate content at scale. Next up, let's generate an image. Let's create a imagegen.ts file. Here we're importing the generateImage function, but it's still in experimental namespace, which means the API might change. But it's stable enough to use in production if you're okay with the potential updates. As usual, we pass in the model and then the prompt. And the results gives you the images as both base64 and uint. Use uint to save directly to the file. And the result, as you have guessed, is an image. Now we can have more control on the size and the quality with the provider options. Each provider has its own settings, and OpenAI lets you pick HD quality or vivid or natural style. And as I mentioned, the response comes in two formats, and you can choose which one meets your needs. And lastly, let's cover text-to-speech and speech-to-text. TTS, as the name suggests, turns our text into natural speech. Let's start by creating a speech.ts file, and very much like the image generation, the speech function are also in experimental namespaces. Again, if you remember the pattern, we will give it the model and the text that we want to convert, but this time we can also choose a voice of the output. We then save the audio, and that's it. That's all we have to do in order to convert text to speech. Now let's go the other way and convert speech to text. We'll take an audio file and transcribe it into text with precise timage for each segment. First, we add the transcribe function to our imports. Again, this is experimental. We then load our audio files into the buffer, and this could be an MP3, a WAV file, or any format that Whisper supports. Then we pass the audio to transcribe it with Whisper model. You get back a full text plus segments with the start and end timestamps. Now each segment includes the text and the precise timings, which is perfect for subtitles, search indexing, or syncing with a video. And this is what the result looks like. You get the text, segment, language, and duration for each part. And this wraps up our core concept. We cover text generation, streaming outputs, tools, images, speech, and transcription. And in the next video, we'll dive into agents, which is autonomous AI that can loop, reason, and execute multi-step tasks. We'll also cover some dev tools for debugging and understanding what's coming next in the SDK. See you there.